Is my screen is visible?
Yes, ma'am.
Screen is visible?
Yes, yes.
Okay. What you are, what is there in the screen? All of you please mute yourself, otherwise it will create echo. So, what you are able to see in the screen? Respond. Is my screen is visible or not? And what you are seeing in the
Yes,
screen?
ma'am. It's visible.
What it is written? There is written.
Simple problem
Yes,
4.1.
yes, yes, yes. Okay. So last class we discussed how to find shear force and bending moment diagram for a simply supported beam for one load, right? Now let's solve one more numerical with the same simply supported beam with 2.2 point loads. Now we have 2 point loads. Okay, the simply supported beam is having 14 kilonewton and one load is 28 kilonewton, and it is simply supported. Okay, so what will be your first part? Your first, all of you write this in your copy. All of you write this in your copy. Write this question in your copy. So find the support reactions. Okay, then you'll find out that your its support reactions are 18 at Ra it's 18 kilonewton and its Rd is 24 kilonewton. So see, there is one, two, three segments. Okay, so I'm making three segments. One, two, three, three. Why I am making these segments? To find out the shear force and bending moment at different positions. Suppose if I had only one load, so I will make one section here and one section here. Okay. Since there are two loads, so this is making three segments. So I'm making a section at this from between A to B, between B to C, and C to D. If there, if you get any question, there are more loads. Suppose D to E, then again make one more section. Means every load should be every load. Um every load will for section A only or for both and AB. Section B, if you have free class, please join. No issue because we have class at 12. Excuse me, ma'am. For this, why 12? 12 is a lunch break, right? Why section B has class at 12? 12 is lunch break. Please respond in the group. Otherwise, it will be issue for me. Section B students can, if they want to join, they can join. No issue. They can take the class. Okay. Okay. No issue. No issue. No issue. For your class, I'll send the video. Already I made the video, but was not able to send because of some reasons. I'll send the video of yesterday's class. Okay, don't worry. Okay, so section A students. So we have discussed with one load. Okay, point load. Now we are taking two loads, right? See if anyone from section B, if they want to leave, they can leave. Okay, if they want to remain, no issues. So I will make three sections. One here, one here, one here. Okay. Now let's see. So this is my first section. This is my first section. I've cut the section. I've made the section at a distance of x. This is my RA. So there will be one shear force. There will be one movement. And just give me a minute. Till then, just find out the reactions. Okay. Find out the reactions by yourself. Okay. So we see this is the section. So I'm taking a section at a distance of x from A. So this is my section. So at every section you will have one shear force and one moment, right? Now we'll see, and this section will be termed as from 0 to, what is the distance between B? It is from 0 to 2 meter. So my first section is between 0 to 2 meter. Okay. For the section AB, that means for this section AB, my limits will be from 0 to 2, and for this limit I'll first find shear force, then I'll find your movement. Okay, I'll find one shear force equation and one movement equation for this section only, right? So let's see. So summation of all, I have drawn the free body diagram. Now see, summation of all the vertical forces equals to 0. And this sign represents, I am taking upward force as positive. So what is the upward force? 18, 18. What is the negative, V is the downward force, so minus V equals to 0. So my shear force becomes plus 18 kilonewton. Understood this part? Now I'll come to the movement part. It is showing, it is taking anti-clockwise as positive. See, it's up to you. You can take anti-clockwise positive, clockwise positive, but whatever you are following in once throughout the equation question, you have to follow. So this person is taking anti-clockwise as positive. So this is anti-clockwise, so he has written positive m. But this will go clockwise, right? This force, this movement about this section, I find to take force into distance. That means 18 into x. 18 into x. And as this sign says anti-clockwise is positive, so my clockwise will be negative. That's why minus 18x plus anti-clockwise moment equals to 0. So I have found out that my shear force is 18 kilonewton and moment is 18x. That means from 0 to 2, shear force will be always 18 kilonewton and your moment will vary as 18 into x. Now there will be two movement from 0 to x, from 0 to 2. Shear force will be same because it doesn't have any x value, right? It will be always 18, and which is positive. But you will have two movement. You will have two movement. At 0, movement will be 0. At x equals to 0, your movement will be 0. But your at x equals to 2, at x equals to 2, you will get a movement. How? 18 into 18 into 18 into 2. You will get a movement. Understood this part? Understood? For 0 to 2, we have founded the shear force. For every section, we have to find out the shear force and moment and find out these values for to draw the your shear force and bending moment. So we have solved this part. Now we'll move to section 2.2. That means this will be the free body diagram of my section. We have not drawn the. Okay, this will be my from. So this will be my from. This is 2 meter, right? This is my 2 meter, and this will be my 5 meter. So my section will become from 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 2 to 5. Earlier my section was 0 to 2. Now my section will become 2 to 5, right? From 2 to 5 at this section. So now I have drawn the free body diagram, right? Free body diagram. This is coming. One more load is coming. Suppose my section is, I'll take a section at a distance x from A. Okay. Always take a section from a distance of x from this. And we know this point load is at 2 meter distance. So what will be the distance of this part? What will be the distance of this part? It will be x minus 2. How much it will be? X minus 2. Okay, so this distance will be x minus 2. Again, I have to take summation of vertical forces equals to 0, summation of movement equals to 0. So if I see the vertical forces, if I want to see the vertical forces, this is x minus 2. Okay, if I want to do vertical forces, so 18 positive, this is downward minus 14, this V is also minus, downward equals to 0. So after solving, I got shear force as positive 4 kilonewton. This part is over. Now comes to movement part. Movement. So movement about this XX section. So I have one force into distance, 18 into x minus, because he has considered anti-clockwise as positive, so this one will be my clockwise. So minus 18x. Done. Then come to this part. 14 into what? How much is the distance? X minus 2. So 14 into x minus 2. This is anti-clockwise. That's a positive. Plus this movement. This is also anti-clockwise. That's why m. So I found out the equation of m as this one. So the equation of so I found out the movement how much? 4x plus 28. Now I have a reason, 4x plus 28. Now my for this condition my v will be same throughout the section. From 2 to 5 it will be 4 kilonewton, right? But movements will be different. First I have to place 2. 4 into 2 plus 28. 4 to the 8. 8 plus 28. How much? 16. 36. So it will be 36 when I am putting x equals to 2. That means at x equal to 2, your movement is 36. And your movement will be something different when you place x equals to 5. Have you got? Have you understood? This part is clear. Please respond in the chat box. Till this part is clear. Shall I move ahead? Shall I move ahead? Ma'am, can't anything? Can't hear anything? From when? When my voice is not clear? Someone unmute yourself and tell me the situation. Are you not able to see my screen, or are you not able to hear my voice? What is the issue? Please write or tell. Otherwise ये सब करने में ही टाइम चला जाता है, क्लास अच्छे से हो ही नहीं पाता है. Repeat once. From which point? Have you understood this part? See, I'm repeating for the last time. Okay, where you don't understand, just write in the chat box. Where you find difficult, please write in the chat box at that moment only. Okay, so I'm again discussing. If I discuss one problem in the whole class, then how will I move to the other problems? No, that is the issue. So see, this is the beam, simply supported beam. We have to find out the shear force at different position, and we have to draw the shear force and bending moment diagram. Okay, so see, these are the two loads. So basically it is see, you generally see it is making three sections. So what you do, you just find the shear force in this section, shear force in this section, and shear force in this section. Again you just find bending moment in this section, and this section. Suppose suppose you have been given a load of only one load, simply supported beam, only one load. So make a section here and make a section here. Simple. Okay. Suppose you have been given a load. Suppose, let me draw again. Suppose you have been given a load like this, UDL. You are making a UDL. Here we'll discuss this kind of problems also. Here you have point load. Okay, and this is also a simply supported beam. This is simply supported beam. There is a UDL for some distance. There is a point load. Here you have B, AB. This is C, D, and this is your E. So what you do, make a section here, make a section here, make a section. You can make a section here. Okay, this much section will be sufficient to find out the shear force and bending moment. So in this question, I have made three questions. As this is making three segments, I have made three sections. So this was my first section. 0 to 2. Second section will be 2 to 5. Okay. Next, third section will be 5 to complete distance. 3, 4, 5, 5 to 7. So this is my first section, 0 to 2. Second, at 0 to 2, you need to find shear force and movement. Again, from 2 to 5, you need to find shear force and movement. And again, for 5 to 7, you need to find shear force and movement. And then finally, you have to place the values like this. Okay, and you'll get the shear force and bending moment diagram. So now for the section first section, this is my free body diagram. Okay, forget about this. They mistakenly they put this section. Forget about this. Just consider this section. So this is the free body diagram. So you have to use equilibrium equation. Summation of all the vertical forces equals to 0. So summation of all the vertical forces equals to 0 will I'll get 18 minus V equals to 0. V equals to 18 kilonewton. V represents your shear force, right? We have discussed. So V is your 18 kilonewton. Then summation of all the movements. So if you see the movement at this point, what will be the movement? Force into distance, 18 into x, and clock. They have taken the clockwise negative, so that's why minus 18x plus this is the anti-clockwise movement, so m equals to 0. That's how we have found out the shear force and bending moment equation for 0 to 1 section. We have found out the values. We have found out the shear force and moment for this section. Now we'll move to another section, 2 to 5. So when you take from 2 to 5, from here to here, you are making a section at this point, right? So either you have to take the right side, either you have to analyze the right side, or either you have to analyze the left side. I'm taking, if you take from left side, it becomes easy. Okay, so I'm taking the left side of this section. The see here also I'm taking left side of the section, right? In this part, I'm taking the left side of the section, right? Next time I'll come to this section, this 222 section. So I'm taking the left part of the section. So whole section will be come. So this is the free body diagram. So this is the free body diagram. RA is acting. We have a point load. So to balance these loads, we have shear force and moment. About this we discussed. When you cut a section, there will always be a shear force and moment. Okay. They are showing. See, they are showing the right hand side. If you cut this section, if you take left hand side, this will be a free body diagram. If you take right hand side, this will be your this will be your free body diagram. So which one is easy to take? This one. So that's why I'm taking left hand side, and I have found out the shear force and bending moment diagram. Okay, and it makes easy to draw the diagram from the left hand side. Again, when you cut a section at this position, this will be your left hand side, this will be your right hand side. So let's start with the left hand side. So in this equation, if you take all the summation of vertical forces equals to 0, you'll find 18 minus 14 minus V. So I have found out the V value as 4 kilonewtons. And the movement will be at this point, what will be the movement? This is the force into distance. So 18 into x. This 18 into x as clockwise is negative. Done. Then I have one more force, 14 kilonewton. And what 14 kilonewton is acting at a distance of how much? How much is the distance? X minus 2. So this distance is x minus 2. So 14 into x minus 2 plus movement equals to 0. Right? So this is my equation. Done. Then we'll move to the next section from 5 to 7. So for 5 to 7, this is the right hand side means yeah, from this is if I make a section, this is the left hand side and this is the right hand side. This is the left hand side equation and this is the right hand side. As I'm taking from the left hand side, I'll start with left hand side only. So if I take the summation of all the forces, summation of all the forces will be 18, this 18 minus 14 minus 28, right? And minus V equals to 0. So this is 24 kilonewton. And if you take summation of all the movements, summation of all the movements equals to 0. Force into distance 18x plus 14 into how much this distance? X minus 2, right? This is 2 meter. So how much will be this? X minus this distance, plus 28. How much this will be distance? This 2 and this 3 and 2 is 5. So if the whole is x and this much is 5, so how much will be this small distance? This distance. This distance will be your x minus 5. Right? So that's why 28 into x minus 5 plus moment equals to 0. So that's how I founded the equation of moment, this one. So basically we got three equations, right? We have got three equations. So we got, let's start with shear force. First start with shear force diagram. At 0 I'm getting 18 kilonewton, and at 2 I'm getting shear force 18 kilonewton. See this diagram. At 0 I'm getting shear force 18 kilonewton, right? At 0 I'm getting 18 kilonewton, so I have drawn the 18 kilonewton. And at 2 also I'm getting 18 kilonewton, so I have drawn 18 kilonewton and I have joined this part. Okay, now let's move to other part. This part is over. For the shear force, this part is over. Now for 2, I'm getting shear force plus 4, and 5 also I'm getting shear force 4. So at 2, I'm having a value of 4. So I have marked a point 4, and again at 5, I'm getting a point of 4. So I have joined this part and I've joined this part. Done. This part is over. Next, at 5, I'm getting a minus 24. And again, I'm getting at 7, I'm getting a minus 24. So at 5 means at 5 meter distance, this is your minus 24. Draw minus 24. Again, at 7, you are getting minus 24. So join this point. I'll get 3. This is my shear force diagram. Understood? Understood the shear force diagram? How we have drawn the shear force diagram? Please respond. Okay. If understood, then I'll move to the bending moment diagram. So see, for 0 to, when I put 0 here, I'm getting moment 0, right? And when I'm putting 2, so m will be your 18 into 2, right? So let's see the bending moment diagram. You guys don't follow your timetable. Section B students are asking me if we have class or not. So at 0, we got how much? At 0, we'll get 0 or not. 18 into 0 is 0. So that's why 0, right? And at 2, if I place 2, how much will be the value? 36, right? So this is the 36. Done. Then we'll move to 2 to 5 section. 2 to 5. So if I place the value of 2 in this equation, what will be my value? 30, same 36, 14 into 2 is 8. 8 plus 20 is 36. So it will be same 36. Okay. Then if I place 5 here, 4 5s are 20, 20 plus 28, 48. So this is my 48. Right. Then this part is over. Then I'll move to the second. If I place 5 in this equation, I'll get 48, same value. That's why 48. And if I put the value here 7, I'll get 0. So this is the 0. So join the dots, you'll get the bending moment diagram. So this figure says that the maximum bending, see from this figure you need to find, when you design you need to find the maximum bending moment. So this 48 is your maximum bending moment. Okay. And from here if you see, and this maximum bending moment is due to this 28 kilonewton load. Okay. and the V diagram reveals that the largest shear force in the beam is minus 24. So the largest shear force in the beam is your minus 24. If CR is there, please tell section B students that those who were present in first class of yesterday's and those who want to present in the second class, they can join the class. I'll give the attendance to them because I have not updated the attendance of second class, so they can join this class so that they can get attendance for the second class. Please pass my message that if from section B students, if anyone from section B is here, please inform that those who have not joined yesterday's second class, if they want to join, they can join now today, and they will get the attendance. Okay. So have you understood this question? Have you understood how to draw this shear force diagram and bending moment diagram for simply supported with point load? Have you understood? Please respond. Have you understood? Then I'll start with UDL. I'll start with
Ma'am.
UDL. Don't write attendance now. Please be present in the class also. Have you understood? Okay. So I'll move to the next question, which is your. So we have discussed simply supported beam with point load. Now we'll discuss simply supported beam with UDL. Okay. Simply supported beam with UDL. So first, find out the support reactions and tell me what will be the support reactions. What will be the support reactions? Tell me. Type in the chat box. Giving 2 minutes. Type in the chat box. What is the support reaction? What is the support reactions in this beam? So your support reaction will be like this. Okay. Roller support will replaced by this one. Your pin support will replaced by these two. Use the equilibrium equation. You will find these are the support reactions. Okay. If you'll get the support reactions. Are you able to find out or should I discuss? Should I discuss or you will should I move on or should I discuss how to find the support reactions for this UDL beam? See how they have solved and why you are not responding. Anyone from section A? Should I explain the support reactions? How you have found? How we need to find the support reaction, or should I move on? Okay. So after finding out the support reactions, what we'll do? If we make a simple one section, it will be if we make a one section here, it will be sufficient. Okay. Suppose let's draw the free body diagram of this one. This is the section. This is the load. This is at a distance of x meter. Okay, and this is the UDL, which is your 5 kilonewton per meter, and you have RA here. Okay, So what will be the, if I see, there will be a shear force and there will be a movement. If I want to see summation of all the forces, vertical forces equal to 0. So Ra minus V equals to will be 0. So your V will be your Ra. That means it will have a value of 7.5. Will have value of 7.5. Okay. Next, if you see the movement, summation of movements about this section should be 0. So it will be Ra into X. This is and clockwise and minus this M equals to 0. So my movement will be your Ra. Okay, it won't. Okay. I did some mistake. Let me explain once again. So if I cut a section at here, it will be like this one. Let me choose another pencil. So this is my section, right? This will be my section. This is the load, 5 kilonewton per meter, and this is the Ra, and this is at a distance of x meter, right? This is at a distance of x meter. So if I and we have one shear force in downward direction and one movement in anti-clockwise direction when we cut a section, right? So if I see summation of all the vertical forces should be 0, so I'll have this Ra, right? Ra this Ra minus this one will be also load. We have UDL, right? So 15 into or how much distance it is acting, x, minus this V equals to 0. So my shear force will be Ra is how much? 7.5. 7.5 minus 5x. Now my shear force will be 7.5 minus 5x. This is equation 1. Now if I want to find summation of all the movements equals to 0, summation of all the movements equals to 0, so what will be my movement? Ra into x, Ra into x minus, this is the positive, Ra into x clockwise the positive, minus this 5. 5 into x, as it is acting on a distance of x meter, into what we used to take? We used to take half of the distance, right? So x by 2 minus this anti-clockwise movement equals to 0. So my movement will become Ra into x means 7.5 into x. 7.5 into x minus 5 x square by 2. So this will be my second number equation. This will be my equation. So my final equation of shear force is 7.5 minus 5x, and moment equation is your 7.5x minus 5 x square by 2. Now you place the value of x from 0 to 3. Okay, for 0 you will get some shear force, and for 3 you will get some shear force. Same with movement. If you place 0, you will get a movement. If you place 3, you will get a movement. So what is the shape of the? This is the shape. At 0, I'll get positive 7.5, and when I place 3 in place of x, I'm getting minus 7.5. Same when I'm getting 0, this is the positive, again it's getting 0. One more important thing you should know, that if you see, I got a equation, right? This is the moment equation I got. Sorry, this is the moment 7.5 into x minus 5x square by 2. I got this is as the moment equation. If I derive it with respect to x, then also I'll get maximum moment. Okay, maximum moment we get when we derive this moment with respect to x equals to 0. So at what position this moment is 0, just derive it with respect to x, you'll get this value. So it says that at x equals to 1.5 meter, you will get the maximum bending moment. And when you derive this one is nothing but your the point where you will get the maximum. So you place the value of x at this position, you will get the value also. Maximum moment is 5.625. Okay. UVL will discuss in the next class. So see, relation between load, shear force and bending. What is the basic relation between these three? When a beam is subjected to more concentrated or distributed load. Please mute yourself. When a beam is subjected to two or more concentrated or distributed load, the way to calculate and draw the shear force and bending moments are the same as in the previous equation. So, rule number 8, mute yourself please. So you will have different shear force and bending moment. Suppose this kind of beam. See, in this beam, you are having a point load. You will have a UDL also. So to find this shear force, there is a way. There is a bit difference as per this rule. It is saying is there is a different way. You can derive it. Derivation will be more easier for these one. So these are the useful tips. Slope of bending moment always determined by the shape of the shear force line. The changes in slope, sagging or hogging also depends on the change in shear force value. When shear force interacts BMD axis, there is a maximum moment. So this is one important point. When the shear force intersects BMD axis, beam axis, there is a maximum moment. When shear force is maximum, bending moment is minimum. So when shear force is maximum, you will get bending moment minimum value at that. Okay. And shear force and bending moment always starts and ends with zero value. Okay, in the next class we'll discuss some complicated beams. Today we discuss UDL and this beam also. One, two, three. Okay, write down this question. Write down this question and submit in the Google Classroom as assignment. Write down this question or take a screenshot of this question and submit in the Google assignment Google Classroom by before Monday. Before Monday, submit this question. Shall I stop sharing or you have taken this question? Done? Have you wrote this question? Just take a the screenshot of this. So this is one assignment for section A. Okay. Now write your roll numbers in the chat box. Yeah, yes. Section B also write your roll number. I'll give the attendance for the last class. Those who were present in the first class, they don't need to give again attendance. Those who were absent in the first class, if they are present today in this class, I'll give the attendance. That was the message I asked to pass down. Those who were absent in the first class, those who were present in the first class, they will get the attendance for the second class also. But those who were absent in the first class, all of you wrote their roll number?